Hello everyone, welcome back to my channel. Today we are going to discuss extra questions related to Chapter 2 Polynomials. So first question is, if alpha and beta are zeros of x square minus 5x plus 6, find alpha plus beta minus 3 alpha beta. So in this type of question, first we will find sum of zeros alpha plus beta by using the relation which we had studied in this chapter, and then product of zeros alpha into beta, which we will get 5 and 6 respectively, and we will substitute both of them in the given expression and solve it. So here alpha plus beta is 5 and alpha into beta is 6. After substituting it, we will get minus 13. In second question, if alpha and beta are zeros of x square plus x minus 1, find 1 upon alpha plus 1 upon beta. Here also we will find sum of zeros and product of zeros by using the relation, and we will take LCM of 1 by alpha plus 1 by beta, which will be alpha plus beta upon alpha into beta. After substituting the values of alpha plus beta and alpha into beta, we will get answer as 1. Next question, we have to find a quadratic polynomial, sum and product of whose zeros are minus 1 and minus 20 respectively. Find zeros of polynomial also so obtained. So first, as we know, the general form of this type of equation is x square minus sum of zeros into x plus product of zeros. So for this we will get the polynomial as x square plus x minus 20. To find the zeros, we will use factorization. We will split the middle term. To split, we need two numbers whose product is minus 20 and whose sum is 1. So the numbers would be 5 and minus 4. After factorization, we will get two factors x minus 4 and x plus 5, from which the zeros would be 4 and minus 5. Next question, if alpha and beta are zeros of fx equal x square minus 4x plus 3, find value of alpha raised to 4 beta square plus alpha square beta raised to 4. Here we will find sum of zeros and product of zeros, and then we will factorize the given expression, in which we will take alpha square and beta square as common term, and alpha square plus beta square would be remaining in the bracket, which we can rewrite by using our identity of alpha plus beta whole square minus 2 alpha beta. After substituting the value of alpha plus beta and alpha into beta, we will get answer as 90. If alpha and next question, if alpha and beta are zeros of 21 y square minus y minus 2, find a quadratic polynomial whose zeros are 2 alpha and 2 beta. In this, first we will find the sum of and product of zeros as we did in the previous questions. Then we will assume as sum and product of the required polynomial which we are required to find as 2 alpha and 2 beta. So S is 2 alpha plus 2 beta. After taking 2 as common, we will be left with alpha plus beta. And we will substitute the value of alpha plus beta from the previous part of the question. Similarly, we will find the product, which would be 2 alpha multiplied by 2 beta, and it will be equal to 4 alpha beta. So the required polynomial would be k bracket x square minus 2 upon 21x minus x upon 21, which would be our required polynomial. Next question, find zeros by factorization method and verify the relation between zeros and coefficients. So the polynomial is 2x square plus 7 upon 2x plus 3 by 4. Here we can see the coefficient of x and constant are in fractions. So first by taking LCM we will bring it to the form ax square plus bx plus c. Then we will use the method of splitting the middle term. In this case, we will need two numbers of which the product is 24 and sum is 14. So the numbers are 12 and 2. After splitting the middle term and taking common from either of the pairs, we will get 2x plus 3 and 4x plus 1. So the zeros would be minus 3 upon 2 and minus 1 by 4. Next part of the question is we have to verify the relation between the zeros and coefficients. So our first relation is alpha plus beta is minus b upon a. LHS is alpha plus beta, which is minus 3 upon 2 and minus 1 by 4. After adding both of them, we will get minus 7 by 4, and RHS is minus b upon a. We will substitute b as 7 by 2 and a as 2, and we will get it all as minus 7 by 4. So our LHS and RHS are equal. For the second relation, alpha into beta is c upon a. Alpha into beta would be 3 by 8 and RHS c upon a would also be 3 by 8. So our second relation is also verified. So we are done with this chapter. If you have any doubt, you can ask in the comment section. Stay tuned. Thank you for watching.